Here we go. We have a question kth element of two arrays. So we have given two sorted arrays, array 1 and array 2, and an element k. Our task is to find the kth position of the combined sorted array. So our first approach will be to use a new array of size n plus m or a list. So in this approach, we will add our array 1 elements as well as our array 2 elements. Then we sort our list or array, and at the end we will find our kth element. In this case, the time complexity, as we are applying our sorting, so our time complexity will be n plus m log n plus m, because the new array size is n plus m. So this is about the time complexity, and our space complexity is n plus m. Can we optimize it? Yes. As it is given, array 1 and array 2 are sorted, and we have to find the kth element. So we can use two pointers. First pointer pointing to 0th index of array 1, second pointer pointing to 0th index of array 2. So we find the smallest element. So in this case, 1 is the smallest element. We will check whether the k is 0 or not. In this case, no. So this is our smallest element. So first we can pick this element. So this is our first smallest element. So this is our first smallest element. Then we increment our pointer. So our pointer points to this value, and our I pointer points to this value. And we have taken an element into consideration. So we decrement our k pointer, k variable, and at some point our k will reach to 0. Then we return our smallest element. So that's all. So its time complexity will be n plus m, and space complexity is constant. Still, there is a scope of improvement. So let's talk about the real approach, the expected approach. So we have this array, array 1 and array 2. We find the smallest array length. Its length is 5 and its length is 4. So we want our first array to be the smallest array. So in this case, this is our smallest array. Second array is our smallest array. In this case, I am talking about size. So we swap our arrays. Now our array 1 look like this, and our array 2 look like this. And we have to find fifth element. So if you carefully observe, we can take 0 elements from array 1. We can take 1 element from array 1. We can take 2 elements from array 1. We can take 3 elements from array 1, or we can take all 4 elements from array 1. So this is a binary search question. This is a advanced level binary search question. So we have to initialize two pointers, L and R. L points to 0 and R points to N. N means we will take all 4 elements, 0, 1, 2, 3 and 4. So we find our mid element. So 4 by 2 is equal to 2, which means first we will take 2 elements. First we mark a cut at this index. So we have taken 2 elements from array 1, and we have to take 5 elements. So the remaining elements is 3 now. So we take 3 elements from array 2, and we mark a cut at here. Let's check. At this point, the left hand side array, all here is the combined left side array, and here is the right combined arrays. So if that makes sense or not. So in this case, as we know, 4 is smaller than 8 because this is sorted, and 6 is smaller than 7. This is sorted. But this 4 must be smaller than right hand side value. In this case, it is 4 is smaller than 7, and this 6 must be smaller than the right hand side. So in this case, yes, it is. So this is the correct point, and our kth element is the maximum from this value and this value. In this case, this is the maximum value, so our answer is 6. I know it's a bit complex, that's why I have taken few examples here. So let's talk about the next example. So our next example is this, and we have to find kth element. In this case, k is 5. Our L points to 0, R points to 4. So 4 by 2 is 2. So we mark a cut at this index, and our remaining elements is 3. So 4 is smaller than 8. We know this is sorted array. So 4 must be smaller than this value also. So this we say this is array 1 and this is array 2, and we mark a cut at this value. So we say this is left 1, and this value we say right 1, and this value we say left 2, and this value will say it right 2. So left 1 must be smaller than or equal to right 2, and left 2 must be smaller than equal to right 1. Means this is a correct position. In this case it is, but in this case 16 is not less than 8. So this is not a correct position, which means we have to change our cut. So we have made our cut at this index, and as you can see this value is greater and this value is smaller. So we have to pick more values from left from array 1. So we have to pick more values or extra values from array 1. We have to increase our range. So if this is if condition, if the range is correct, if the cut is correct, else if the cut is not correct, and in this case L2 is greater than R1, L2 is greater than R1, means we have to increase the range of array 1. So we increase the range L, we initialize it to mid plus 1. We will increase the range. So mid is 2, now L points to 3. L points to 3 here. So 3 plus 4 by 2 is equal to 7. 7 by 2 is equal to 3. We make a cut at this value. So this is our cut. We have taken 3 elements from array 1 and our remaining elements is 2. So we take 2 elements from array 2. Now we check the range. Is 8 less than 16? Yes. Is 3 less than 10? Yes. So this is the correct cut. As you can see, all the 5 values, all the k values on the left hand side is smaller than all the values on the right hand side. Then we find our maximum value, our kth value. So we find the maximum between L1 and L2, and our maximum value is 8. We will return 8. That's it. Let's talk about next test case. L points to 0, R points to 4, 4 by 2, 2. We have to find fifth element. So we take 3 elements from here. 14 is not less than 4, means there is a lesser element on the array 2 right hand side. So we have to decrement our array 1 length. So here we have else condition. We don't need to write this condition, it will directly go to else condition. So we find and decrement our range or decrease our range. Now our R points to uh, our R, our mid is 2, so our R points to 1, R at this index. So 0 plus 1, 1, 1 by 2, 0. So we take 0 values from this, from array 1, and we take all 5 values from array 2. But in this case, as you can see, L1 and R1, L2 and R2. How we take these values? If we write a condition here, so our L1, we have to find our L1. If our cut 1, this is our cut 1 is equal to 0, so we cannot take our cut equal to 0, so we cannot take left hand side value. So in this case, I will take minimum value, integer minimum, because this must be smaller than the right hand side of array 2. So that's why we have to take the minimum. Else we take our left hand side value. So from array 1, this is our array 1, we have to take cut 1 minus 1th value, because as we mark a cut at this value, at this index, 0 index, so we have to take left hand side value. That's why cut minus 1. And if we talk about right 1, if we mark a cut at nth value, so we cannot take, in this case we are making a cut at the nth index, so we cannot take the right hand side value. That's why we have to take maximum, or we will take cut 1 value if this is a valid index. Same goes for L2 and R2. So let me copy the values here. But we have to take value from array 2. This is array 2. This is cut 2, array 2, and here our length is m. This is L2 and R2. But this is cut 2. But what is cut 2? Cut 2, cut 1 we know, cut 1 means middle value. Middle value we can find it. And cut 2 means we have to take the k values. So we have taken mid values or some values from array 1. So we decrement those values, and remaining values we have to take from array 2. So it is cut 2. That's all. So this value, minimum value, our minimum value is less than R2. In this case, it is correct. And our L2 is smaller than 10. Yes, it is correct. So this is our correct index. So we have to find between these values. So our L1 value, which is the minimum value, and this value. So our maximum value is 5. So we'll return 5. The question is pretty simple now, but we have some edge cases. So edge cases we have at this. Suppose our k is 2. We have to find k values, 2 values. So our L points to 0 and R points to 6. Let me write it here, 6. But you can see we have to take only 2 values. So why you are incrementing or increasing your range, array 1 range? We have 6 values here, but we don't require 6 values, we only need 2 values. So if our n is greater than k, means we have a bigger range that we does not require. So we change our r to k. We only need 2 values. So now our r points to 2. That's it. Uh, Previously, our r points to n, which is not a valid index. Now our r points to 2, which is not a valid index, because our 2 values we have to take from these two or either these two. That's it. And one more thing on this test case, uh, suppose we have to find 5 values. So L0 and R3. But in this case, our M only contains 4 values. So we have to take one value from array 1 no matter what. We have to take one value from array 1 because our array 2 length is less than k. So if our M is less than k, so we have to take the remaining values from array 1. We have to take one value or the remaining value from array 1. We don't have any other choice. So we have to update our L. In this case, we will update to k minus m. Every case we will change it to k minus m. Our k is 5 and our m is 4. So the remaining value is 1. We have to take one value from array 1. So our L points to this value. That's all. These two conditions we have to write, and this is our L1, R1, L2, R2, and this is the if condition which we have to utilize in our binary search. So let's first implement it, then we talk about the time and space complexity. So we first find the n and m. The code is exactly same in Java, but I'm coding in C++. If you need any help in Java, then comment down below. I will provide you the code. So if n is greater, but we want our array 1 to have less size, so we swap our array 1 and array 2 values. Initially, this is our condition. If our array 2 length is smaller than k, then we have to take the remaining values from array 1. This is it. And if our array 1 length is bigger than k, so we have to shorten our range. So our r points to k else n, and we have minimum and maximum value. This is our range. First we find our mid value, then we find our left one. If our mid points to 0, then take your minimum value. This is our minimum value, else take mid minus 1 value. This is our right, and the remaining values. This is cut 2. So this is left 2, same as left one and same as left one and right one, but on array 2. So then we have condition. If the cut is valid, then find your maximum values from left hand side 2 values, or our left one is greater, then we have to shorten our range, as we have to increase our range. That's it. At the end we have to return a null value or any invalid value. Let's submit this code, and let's talk about the time and space complexity. Here we have to do one thing, std, then submit this code, and in between let's talk about time and space complexity. our time complexity, as we are applying binary search. So in binary search, we have a time complexity of log n, but in this case, we are first finding our minimum from n and m. So our time complexity is order of log minimum n and m, and the space complexity is constant. If you have any doubts, feel free to ask in the comment section. I know there is a lot of approaches for this question particularly, and maybe the approaches will work or maybe not.